As more and more embedded systems are connected to the internet, there are novel vulnerabilities that have to do with cloud-connected devices. When embedded systems meet internet security, things can get very complicated because you need not only good practices for IT enterprise security, but you also need good practice for embedded system security, and they aren't quite the same. So you need people who know both sets of practices to really get there. Don't forget, if you have a cloud server that can control thousands of embedded devices, if someone gets into the cloud server, now they have the ability to mess with thousands of embedded devices. That gives them a much bigger multiplier than simply breaking into a single machine. This picture is obviously faked, but the idea is, what if somebody were able to get into tens or hundreds of thousands of thermostats across the country and do coordinated attacks against the electric grid by cycling air conditioning in a synchronized manner? Those sorts of attacks have been imagined for a while, but as the number of internet-connected devices grows, the issue of having to deal with those kind of attacks becomes more real all the time. If you're building an internet-connected device, here are some questions to ask. How does the cloud server know it's a legitimate device? Sometimes you are selling a service, not just the device, but also a service on the cloud, and you only want to provide that service to legitimate devices and not to counterfeits. Otherwise, someone else could make counterfeit devices, charge a high price, and that leaves you to provide service to a customer who didn't even pay you to buy a device. One way to do this is to deploy each device with a unique public key signed by the factory and require authentication with the cloud server. Another question to ask is, how does the user securely connect a smartphone to the device? If the initial key transfer is in the clear, then in principle, anyone overhearing that transmission can get the key to the device. A common technique to address this is to print a unique key or code or password on a sticker inside the unit, but that now means you have to coordinate the programming of the unit with the sticker to make sure the sticker matches what's inside the unit. And what if a user forgets a password? You need a factory reset ability. You do not want a shared master factory password because that's bad, but you need some sort of way to get the system back to the state where it can accept the initial user password. And finally, ask yourself, how do you plan to do secure update? How do you know that the user won't download software from a rogue server someplace that compromises the system? And what do you do about factory key revocation? If you're doing secure updates with signed updates, if the signing key gets loose, what's your plan for revoking that so that you use a new factory key and you can only use new signed updates? If you don't think through that, you may have a bunch of systems that have to be scrapped and replaced if you have a loss of control of the factory signing key for firmware updates.